Ideally, in a high-permeability saline aquifers, normally the permeability could be high, and really the rock property could be really enough to avoid the hydraulic fracturing stimulation of this type of reservoirs. But in reality, what you are expecting as a high permeability or high rock property is not really valid all the time. There is some cases where you are going to be able to deal with low permeability environments, or you can have some really damaging issues during the completion or drilling process, and this is going to affect the injectivity of the CO₂, especially in the disposal well. Hydraulic fracturing is normally used to improve the CO₂ disposal rate, and this is really one of the most effective ways to assure the long-term injectivity of CO₂ and at the required volumes and also in the required conditions. And hydraulic fracturing is going to be really one of the key technologies you are going to be really required to implement, especially to improve the injectivity of the well. This is really also important, especially for the horizontal or could be vertical wells. So CO₂ disposal rates and long-term sustainability are really the key components of any CCUS project's economics. So, because the sustainability of the CO₂ disposal needs to be around 10,000 tons per year or per day, which is really almost 3.7 millions of tons per year. So, we need to assure this type of or this level of injectivity for almost 20 or 30 years of time. And to be able really to assure that, it's really important to drill the well in taking in consideration the CO₂ disposal projects, especially if you are going to face, for example, something like injectivity issues associated to the architecture of the wellbore. We are talking about that could be the horizontal or vertical wells. And especially if we are going to have issues with the injectivity, it's really important for us to assure that we're injecting CO₂ along the effective area of the wellbore. So it means that it's really important for any CCUS project to drill the proper well to assure that we are going to be able to inject the CO₂ for a long time and also at the required volume. So since you are dealing with the CO₂ disposal wells and knowing that our main objective is to dispose in the permanent way the CO₂, one of the really key parameters or key fluids, especially to assure the proper stimulation of the wellbore, could be foam. And in the foam family fluids, you were talking about could be nitrogen CO₂ foam or nitrogen or could be CO₂ foams. And for the type of the CO₂ disposal, it's really more effective to use CO₂, the supercritical CO₂, because you are going to be able to handle the CO₂ in the liquid phase. And this is something we already also documented in the SP paper 217816. As we documented in the SP paper 217816, one of the key steps, especially to assure that you are going to be able to fracture effect in the CO₂ disposal in an effective way, is to design the treatment in using the proper simulation tool. So for this purpose, you can use FracPro, and FracPro has the capability to use the foam system. Could be the different types of foam system, or could be CO₂ foam systems. And using this software, you are going to be able to consider the variations of the rates, the variation of the pressures, and also the variation of the foam quality, especially during the placement of propane at the different conditions. And remember that, especially when you are fracturing CO₂ disposal wells, and assuming that you are really working in a high-permeability saline aquifer, it means that you are going to face issues with a high leak-off, and the high leak-off is going to be translated really in potential screen outs. And the foam system, especially the CO₂ foam system, is really the most adequate system, especially to reduce leak-up and also to be able really to transport the propane from surface to downhole. And this way you are going to be able to pack the fracture in the proper way.